What if the universe is full of life, but physics says we can never meet them? You know, I have a friend who is an artist, and he holds up a flower and says, "Look how beautiful it is," and I agree. Then he says, "I as an artist can see how beautiful this is. But you as a scientist take this all apart and it becomes a dull thing." And I think that he is kind of nutty because I see more. I see the cells in there. I see the complicated actions inside which also have a beauty. I see the way the colors evolve to attract insects to pollinate it. It is interesting because it means the insects can see the color. Now, why do I bring up a flower when we are supposed to be talking about aliens? Because the universe is like that flower. When you look up at the night sky, you see the beauty. You see the silence. You see the infinite black ocean, and your intuition, that marvelous, sloppy, evolution-built tool inside your skull, it tells you something. Something. It screams at you that it cannot be empty. It is too big to be a waste of space. You do the math in your head. Billions of stars. Billions of galaxies. Even if life is rare, even if it is a 1 in a billion accident, there should be millions of civilizations out there. They should be noisy. They should be messy. They should be broadcasting "I Love Lucy," reruns across the spiral arms. So where are they? This is the great question, the Fermi Paradox. But I want to suggest to you that the reason we do not see them is not because they are hiding. It is not because they are shy. It is because the universe is not built the way you think it is. The universe is not a box. It is not a stage where you can just walk from stage left to stage right if you have enough time. The universe is a machine, a rigorous, unyielding machine governed by laws that do not care about your desire to have a conversation with someone from another star system. We are going to take this machine apart. We are going to look at the gears, and we are going to find that the very laws that allow us to exist, the laws that hold your atoms together, are the same laws that lock the door and throw away the key. Let us start with the most fundamental illusion you have. The illusion of, now imagine you are sitting in a room. You see me and I see you. We think we share the same moment. If I clap my hands, you see it happen. If something happens on the sun, we think it happens now. Isaac Newton thought this way. A brilliant man, maybe the smartest man who ever lived. He gave us a picture of the universe that was like a giant clock. Tick. Tock. The time on Earth is, the time on Mars is the time on Alpha Centauri. If the sun vanished, Newton's math said the Earth would instantly fly away. The gravity would stop, bam, instant. But nature said no. Nature played a trick on us, and it took hundreds of years to figure it out. It started with electricity. Think about a magnet. You have a magnet here and a compass needle over there. You wiggle the magnet and the compass needle wiggles. How does it know? Is there a string? No. Is there a fluid? No. Michael Faraday, a bookbinder who did not know much mathematics but had a wonderful imagination. He visualized lines of force. He saw the space between the magnet and the needle, not as empty nothingness, but as a medium, a field. Imagine a swimming pool, a vast, calm swimming pool. If I am in the middle and I splash the water right next to me moves. Then that water pushes the next water, and that water pushes the next water. It takes time for the splash to reach the edge. This is the secret. The field is real. The electromagnetic field is like a jelly that fills the universe. When you wiggle an electron, you shake the jelly. A wave travels out. We call that wave light. Now, here is the kick. Here is where reality gets weird. That wave in the jelly has a speed, a fixed speed. It is determined by how stiff the jelly is and how heavy the jelly is. In physics terms, we call these the permittivity and permeability of free space. You cannot change it. You can scream at the wave. You can push the wave. But the wave travels at the wave speed 300,000 kms. So if the sun disappears, the gravity wave, the ripple in the space-time jelly has to travel to Earth. It takes 8 minutes. For 8 minutes, the sun is gone. But we are still orbiting nothing. We are orbiting a ghost. We are orbiting where the sun was. This delay is not just an annoyance. It is the fundamental speed limit of cause and effect. It is the speed of causality. If you could go faster than this speed, if you could send a signal instantly, you could break the universe. You could send a message back in time. You could kill your own grandfather. The universe protects itself from these paradoxes by imposing this limit. So, think about our aliens. They are over there in the Andromeda galaxy 2 million light-years away. That means the news of their existence takes 2 million years to get here. But it gets worse. It is not just about the delay. It is about the cost. Let us talk about energy. You have heard the equation EFmc2. Everybody knows it. But nobody thinks about what it really means. Really means. It means energy is mass. When you pick up a rock, it has mass. It is heavy. Now, if you heat that rock up, if you make the atoms inside it jiggle faster, the rock actually gets heavier. Not much. You cannot feel it, but it is measurable. The energy of the heat adds to the mass. Now imagine a spaceship, a big, beautiful spaceship. You want to go to the stars, you turn on the engines, whoosh. You push. The ship goes faster. You have added kinetic energy, which is motion energy, to the ship. Since energy is mass, the ship has gained mass. It is now heavier than when it was standing still. You push again, it goes faster. It gets heavier. As you get closer and closer to the speed of light, that speed of the ripple in the jelly, the ship becomes incredibly heavy. The mass shoots up towards infinity. Infinity. To get that ship to reach the speed of light, you would need infinite energy to push the infinite mass. There is not infinite energy in the universe. So, you are stuck. You can get close. You can get to 99%, maybe 99.9%. But every decimal point costs you more than all the energy the human race has ever produced. Nature says you can look, but you cannot touch. I used to work with cyclones. We take tiny little particles, protons or electrons, and we spin them in circles using magnets. We push them with electric fields. Kick, kick, kick. Faster, faster, faster. And you know what happens? As they get near the speed of light, they get so heavy that the magnetic field cannot hold them in the circle anymore. They fly out. We have to design the machine to account for the fact that the electron, this tiny nothing of a particle, becomes a monster of mass. This is not theory. This is engineering. We build machines based on this. So when people say, oh, the aliens will have warp drive, they will have anti-gravity, they're talking about magic. They are assuming the laws of physics are wrong. But the laws of physics are the most tested things in human history. The door is locked by the weight of the universe itself. But wait, you say, maybe they do not need to go fast. Maybe they just take a long time. They have cryosleep, they have generation ships. Well, now we have to talk about time, and this is where your brain is going to hurt a little bit. That is okay. It is supposed to hurt. We think time is a flow. Past is gone. Future's not happened. Now is the only thing that is real. Einstein taught us that this is wrong. Imagine a loaf of bread. No. Better yet, imagine a sausage. A long, infinite sausage of space-time. One end is the Big Bang. The other end is the heat death of the universe. The whole thing exists at once. It is a block universe. You and I, we are slicing this sausage. R now is a slice straight across the sausage like slicing a cucumber. Everything in that slice happens at the same time. But if someone is moving, if an alien is in a spaceship moving relative to us, they are slicing the sausage at a different angle. This is hard to visualize. Let me try it this way. Imagine you are on a train. I am on the platform. The train is moving. You shine a light from the floor to the ceiling. To you, the light goes straight up and down, simple. But to me, watching from the platform, the train has moved while the light was traveling. So I see the light go up at a slant and come down at a slant. It travels a triangle path. The hypotenuse of a triangle is longer than the vertical side. So for me, your light traveled a longer distance. But remember, the speed of light is constant. It cannot change. So if the light traveled a longer distance at the same speed, it must have taken more time. Your time has slowed down relative to mine. This means time is personal. It is private. My clock and your clock do not agree. Now apply this to the galaxy. If there is an alien civilization in the Andromeda galaxy and they start moving towards Earth, their slice of the sausage tilts. Then now what they consider to be happening at this exact moment suddenly sweeps into our future. If they stop and turn around, then now sweeps into our past. We are not living in a shared reality. We are living in a collection of private time bubbles floating in a four-dimensional geometric block. This separation means that contact is a very messy idea. By the time they see us, we might already be dead. By the time we see them, they might not have been born yet. The universe is vast, not just in space, but in the disconnect of time. Okay, Feynman, you say, forget the spaceships. What about radio? Why do we not hear them on the radio? I love radio. It is just light that you cannot see. It is the same wiggling of the electromagnetic field, just slower wiggles. But there is a problem called the inverse square law. Imagine I have a can of spray paint. I spray a dot on the wall from 1 inch away. The paint is thick. It is concentrated. Now I back up 10 feet. I spray for the same amount of time. The paint spreads out. It covers a huge area, but the layer of paint is very, very thin. You can barely see the color. Radio waves are like that spray paint. They spread out in a sphere. As the sphere gets bigger, the energy is spread thinner and thinner. By the time a radio signal travels 100 light-years, which is just next door in our galaxy, the signal is so weak, it is barely a whisper. But wait, it gets worse. The universe is not quiet. The universe is hot. Not boiling hot, but it has a temperature. The Big Bang left behind a glow. The stars are pouring out noise. The dust clouds are radiating heat. Even the atoms in your radio antenna are jiggling because of heat. That jiggling creates electrical noise. Static. Static. If the alien signal is weaker than that static, you can never ever hear it. It is mathematically impossible to dig it out. To send a signal that is louder than the background noise of the universe across 1,000 light-years, you need a transmitter with the power of a sun. You have to scream so loud that you burn up your own planet just to say hello. Would a smart civilization do that? Would they waste their entire planetary energy budget just to see if anyone is listening? Probably not. They would stay quiet. They would listen like us. And if everyone is listening and nobody is shouting, the galaxy is silent. Now let us look at the receiver. Us. What are we? I find this to be the most miraculous thing of all. We are atoms. Hydrogen, oxygen, carbon, nitrogen. The same stuff that is floating in the dead clouds between the stars. But these atoms have done something impossible. They have arranged themselves. In physics, we have a law, the second law of thermodynamics. It says that things tend to get messy. Entropy increases. If you build a sandcastle, the wind blows it down. The wind never blows the sand into the shape of a castle. Disorder is natural. Order is unnatural. Yet, here we are, a collection of atoms that is so highly ordered, so incredibly structured, that it can think about itself. Think about the machinery inside one single cell of your body. There are little molecular trucks carrying cargo along tiny highways. There are library systems reading the DNA code. There are power plants burning fuel. It is more complicated than New York City. And it is all packed into a microscopic blob. For this to happen, for dead matter to wake up and become a civilization, requires a chain of accidents so long, so unlikely, that it makes winning the lottery look like a sure thing. You need the right star. Not too big. It burns out too fast, not too small. It flares and kills everything. You need the right planet. You need the right moon to stabilize the tilt. You need a magnetic field to protect the atmosphere. You need liquid water. You need the spark of life. You need the leap to multicellular life, which took billions of years on Earth. You need to avoid the asteroids. The probability of all these gates unlocking in the same place is vanishingly small. Maybe the door is not just the speed of light. Maybe the door is the probability of existence itself. We might be the only ones who made it through the gauntlet. So we have a universe where travel is physically impossible due to the energy costs. We have a universe where time is fragmented and relative, making now a meaningless concept across distances. We have a universe where signals drown in the noise of the Big Bang. And we have a universe where life is a statistical miracle. Does this depress you? I have students who come to me and they say, "Professor, this makes me feel so insignificant. We are just a speck. We are trapped in a bubble." And I tell them, you are looking at it upside down. If the universe was teeming with aliens, if they were landing on the White House lawn, if they were handing us the answers to cancer and fusion power, then we would be nothing. We would be children. We would be pets. We would be the primitive tribe waiting for the gods to save us. But if we are alone, if we are the only ones, then we are the most important thing in existence. We are the eyes of the universe. We are the way the universe knows it exists. Without us, the stars are just nuclear furnaces burning in the dark with no one to admire them. Without us, the laws of physics are just blind machinery grinding away with no one to understand them. The fact that we are trapped here by the speed of light and the laws of relativity forces us to grow up. It forces us to solve our own problems. We figured out the distance to the stars, not by going there, but by using our minds, by using geometry, by using the parallax effect, looking at a star in January and then in June and measuring the wiggle. We figured out what the sun is made of not by dipping a spoon in it, but by splitting its light with a prism and reading the barcode of the atoms. We did this. Us, the jiggling atoms. The silence of the universe is not a rejection. It is a challenge. It is nature telling us, I have given you a safe laboratory. I have put up the walls so you do not hurt yourself or get hurt by others. Now show me what you can do. So go back to that flower. The scientific view does not remove the beauty. It adds to it. It adds the mystery of how such a thing could arise from the chaos. The same is true for the sky. When you look up, do not wish for spaceships. Wish for understanding. The aliens are not coming. The door is locked. But look at the room we're in. It is a magnificent room. It is filled with light and gravity and particles and fields. And we have the key to understanding all of it right here in our equations, in our experiments, and our curiosity. We do not need them. We have us. And if you think about it, that is enough. That is plenty. If you want to join us in this room, if you want to keep exploring the machinery of reality, make sure you subscribe. We are going to keep taking the watch apart until we see every gear. Thank you for listening. Now go outside and look.